Hi everyone, I hope you're okay. This is video number 11, guys. Just take screenshots, answer the questions on your own. And if you're not sure about your answers, just come back and yeah, and see where you went wrong. Before I start answering this thing, guys, I just need to make sure that I analyze each and every compound individually. If I'm given a condensed structure, I must draw a structural formula and then write down the IUPAC name. If I'm given an IUPAC name, I must just draw a structural formula. If I'm given a structural formula, I must just write down the IUPAC name. So, compound A is a semi-condensed structure. So I just need to draw a complete structural formula. I have CH3, then I have a carbon that has a bromine ion, as well as CH3. And then I have CH2, and then I have a carbon that has a side chain as well as a hydrogen, and then I have a CH3, and then I have a CH3 over there. I can see that these two carbons, which ones? Oh, there's an H over there. I didn't see it. Okay. Oh yeah. This would be the structure, yeah, guys, and this will be the longest chain. And the IUPAC name will be 2-bromo, and then 2.4. I have 1, 2, 3, 4, 5, and 6. It's 2.4.5 trimethyl hexane. That will be the IUPAC name, ne? And this thing will be a haloalkane because of this. Okay, and then compound B, I'm given a structure. That's easy. All I have to do is to write down the IUPAC name. This will be but 2 in. Between carbon number 2 and 3, I have a double bond. So I'll always pick a lesser number. Okay, compound C, we have an IUPAC name. All we need to do is to draw a structural formula. Let me try to squeeze it over here. Pent 2 in. That's 1, 2, 3, 4, 5. My structure will be like that. Pent 2 ins, pent 2 in, and then all I have to do is to write the hydrogens around. Okay. Compound D, let me try to squeeze in the structure over there. I have CH3, CH2, CH2, and then C with an OH, like that. I'm dealing with an aldehyde, and its IUPAC name, since it has 4 carbons, is just butanol. Okay, and then compound E, let me draw the structure. It's a ketone. Since the suffix is -one, it has 4 carbons, and then carbon number 2 is the one that has a double bond. I'm dealing with the ketone over there. That's the structure. And then compound F, it's 4.4 dimethyl pent 2-ine. My parent chain has 5 carbons together, so it will be 1, 2, 3, 4, 5. Between carbon number 2 and 3, I have triple bonds, like that. And then all I have to do is to just make sure that my carbons are fully bonded. Then I'm told that, excuse me, it's 4.4 dimethyl pentane. 1, 2, 3, 4. This would be the the structural formula, guys, of my 4.4 dimethylpentane, and this is an alkyne, by the way. That's an aldehyde, as I've mentioned. That's a ketone, alkene, haloalkane, alkene as well. Okay, now let's go to compound G. Compound G is just butane. The parent chain has 4 carbons and this compound has single bonds between adjacent carbons. So this will be the structural formula for butane. And then compound H, let me use a different color. I have CH3, CH2, another CH2 with a C double bond O with an H. And this type of a compound is a carboxylic acid. Carboxylic acid. Its IUPAC name is just butanoic acid. It's butanoic acid. Okay, now let's answer the questions, guys. Must write down the letter that represents a ketone. We said a ketone is compound E. That has a general formula of CnH2n-2. This is general formula for alkynes. And our alkyne is just compound F. We can see our suffix is I in there. And then a compound that is an isomer rather of 2-methylbutene. 2-methylbutene. 2-methylbutene, guys, is an alkene that has 5 carbons. The only alkene that has 5 carbons is compound C. Okay. 2.1.4, a compound that has the same molecular formula as ethyl ethanoate. The only compound that will have a the molecular formula which is the same as that of an ester is always going to be a carboxylic acid. Together. So compound H has the same molecular formula as ethyl ethanoate. 2.2.1, we must write down the IUPAC name of compound A. We said it's 2-bromo, 2.4.3 trimethylhexane. 2-bromo, then 2.4.5 trimethylhexane. Okay, now we must write down the structural formula of compound F. Already did that. To be like this: CH3, CH2, another CH2, and then a carbon with double bond O. This will be the structural formula of our butanoic acid over there. Then 2.3, we are focusing on compound D. What is compound D? Compound D is an aldehyde, okay, and its IUPAC name is butanal. Write down the homologous series to which it belongs. We just said it's an aldehyde. The name of the functional group, that's formyl. And then the structural formula of its functional isomer. Always the time, guys, aldehydes will always be isomers of ketones together. So to answer this question, you must just write the structural formula of a ketone that has 4 carbons. So you simply have butane-2-one. This is the structural formula, guys. Just butane-2-one. Okay, now let's go to compound G. G is butane, okay? The IUPAC name of a chain isomer of butane There's only one chain isomer of butane, and that's methyl propane. It will be 2 methyl propane. Okay. A balanced equation using molecular formula of for its complete combustion. What do we have? Butane, right? That's C4H10 plus oxygen. This has to give us carbon dioxide and water. All you have to do, guys, is to just balance this equation. I have 4 carbons on my left hand side. That means I must also have 4 carbons on my right hand side. I have 10 hydrogens on my left hand side. I must also have 10 hydrogens on my left hand side. Now, let me see how many oxygens do I have. I have 5. 5 plus 8, that's 13. The coefficient over here should be always half of this. Are we together? So I'll say 13 over 2. But obviously, guys, whenever I write down my stoichiometric coefficients, I must not write them as fractions. That means I must multiply each and every organic molecule by 2. I will have 2C4H10 plus 13O2, giving me 8 CO2, and then 10 waters. Okay, let me see. How many carbons do I have on the left hand side? 2 times 4, that's 8. On the right hand side, I also have 8. How many oxygens? That's 2 times 10, that's 20. On the right hand side as well, I have 2 times 10, which is 20. And then oxygens, I have 13 times 2, which is 26. And then on the right hand side, I have 16 plus 10, that's 26. So my equation is balanced. That's how, guys, I was supposed to tackle this question over here. Né? Please note that, guys, for the first section of organic chemistry, we are done with the questions. The first 11 questions, they deal with these types of questions, whereby I have to draw the structural formula, write down the IUPAC name, define homologous series and stuff. You'll only find that within the first 11 videos. For the next 11 videos, from video number 20, from video number 12 until video number 22, or rather 23, I'll be dealing with intermolecular forces. And then from video number 24 going upwards, I will be dealing with chemical reactions, organic reactions. Just stay tuned, guys, and wait for more videos. Bye.